Today I'm going to be showing a Newton's second law problem, so let's take a look. I have a couple of boxes, one of them sitting on a slope, one of them is dangling off a string that is attached to the first box over a pulley. The angle of the slope is 40 degrees, the coefficient of friction on the slope is 0.3. The mass of the larger box is 3 kilograms and the mass of the smaller box is 2 kilograms. We want to know what the acceleration of this larger box is going to be. Of course, they're attached to each other, so they should have the same acceleration. Let's start the way we always start these problems, which is by drawing a Freebody diagram. I'll start with the forces on this smaller box. We've got the force of gravity, and we have tension. And that's all we have. Those are all the forces on that smaller box, so that is a pretty easy one. Let's now look at the forces on this larger box. We have gravity going down, a normal force, which is always perpendicular to the surface. I have tension, and then I have friction. But here's the thing, I don't know which is stronger. I don't know whether this tension force is going to be stronger or whether the component of the force of gravity that pushes that box down the hill. Friction is always a force that resists sliding. But which way is this going to be sliding? I don't know. I'm going to have to figure that out before I figure out which direction the force of friction will be. So the intermediate question I want to answer before I can answer the question that's given: what direction would the box accelerate without friction? And then I can figure out the direction that friction will be acting. Of course, that is assuming that we're starting at rest, because friction always opposes sliding. If we were starting with some motion, friction would be trying to oppose that motion right off. I want to choose a good coordinate system for my problem. And we do have this slope here, so I'm going to have to take my coordinates and tilt them a little bit. So I think I will have positive x be going up the slope, and I'll have positive y be perpendicular to the slope. I have to remember that once this passes over this pulley, that's going to shift such that positive x is going to be going down over on this side. We can kind of think of it as any force that makes the wheel turn clockwise is positive x, and any force that makes the wheel turn counterclockwise is negative x. Alright, so let's go on to the next step, which is to find components of our forces. I'm going to move this label over here. And I'm going to find the x and y components of the force of gravity in the directions that I've chosen. So I chose an x direction which goes this way and a y direction which goes this way. I now have to make components such that, let's see, my y component is this way, it's in the negative y direction, and my x component is this way, it's in the negative x direction. This is a similar triangle to this larger one, so this is going to be a 40-degree angle. If I want to find those components, I'm going to go FGX is equal to FG sine of 40, or MG sine of 40, M1G. I think I'll go ahead and leave that in symbols for now. I'll plug in the numbers later. FGY is going to be M1G cosine 40. And I just use M1 because I'm just figuring out the force of gravity on this particular object. So now I've broken these into components. Now I get to sum up forces in the x and y direction. In the x direction, that sum of forces, I'm going to have the force of gravity on the other mass in the positive direction. I have the force of tension in the negative direction. I have another force of tension in the positive direction. I have force of gravity in the negative x direction. And, friction we just don't know. We don't know. Is it going this way? Is it going this way? We don't know. So for now, I'm going to figure out what the acceleration would be without friction, and then we can figure out which way friction is going to go. All of these is going to equal to the sum of masses, all the masses put together, since these are all causing the system to accelerate, m1 plus m2 times the acceleration in the x direction. So I'll go m2, this one I figured out over here. By the way, these two forces of tension, I went ahead and canceled them out. The reason why is because in my class we can always assume this wheel is frictionless, we can assume it's massless, and these are two opposite ends of the same string. The tension is going to be the same everywhere in the string. I'll plug in numbers now. Alright, and it's a bit of a close call, but it looks like the acceleration is going to be in the positive direction, up the slope. I find that it's 0.14. So it looks like the friction is going to go in this direction. So now I can sum up all my forces in the x direction, including friction. Here's the thing, to figure out friction, I always have to find normal force. So let's sum up forces in the y direction so I can figure out normal force. Normal force minus force of gravity in the y direction. In this y direction, we're not going to have any acceleration. We're not going to have this box sinking into the slope or jumping up out of it. So in the y direction, our acceleration will be 0. The normal force is equal to FGY, which I already figured out was m1g cosine 40. That means the force of friction is going to be mu times the normal force. So that'll be 0.3 times, normal force is here, m1 is 3, we have 9.8, and we have cosine 40. Okay, so now I have the force of friction and I have all the other forces acting. We know the direction of the force of friction, so we can actually add up what the acceleration would be. I'm reminding you that this would be the acceleration without friction. I will come back and label it. Now I can work in my x direction. The actual sum of forces in the x direction is going to be the force of gravity on this one, which was G2, I called it. The two tensions which cancel out, the force of gravity in the x direction. And alas, now we know friction is in the negative x direction. It's going to be m1 plus m2 times acceleration, m2 times g, minus m1g sine 40, minus, we just figured out this is 6.76. This is 5 times the acceleration, and 2 times 9.8 minus 3 times 9.8 times sine 40. And if I solve for acceleration here, I'm going to get negative 1.21 meters per second squared. And now I have to apply my brain, because something has happened here, something that is impossible. What I've said is that if there were no friction on this slope, the box would slide up the slope. And now I've said that with friction, the box is going to slide down the slope. Clearly this doesn't make any sense. What's happening here is that this coefficient of friction is not being fully utilized. You have to remember that when we talk about coefficient of friction, that coefficient is going to be less than or equal to. Maybe I should have put that right away, but I think that is a little bit more confusing to work with. What we found here is that friction is going to be strong enough to keep that box on the slope as it is. Therefore, the acceleration is not going to be downwards because, of course, friction isn't going to pull the box down. The friction force isn't going to be that strong. It's going to be a little weaker than that. And in reality, it's going to just perfectly balance out the other forces such that the acceleration is 0. And that is our answer. These problems are good for practice. Let me know if you have any questions, leave me a comment. Hopefully this is helpful to you.